Okay, good afternoon, everybody, and welcome back to Sunoikis' Digital Classics. Today is our session 12 of this summer term 2020. And today it's a pleasure to welcome back our guests, Angelos, Barmpoutis, and Eleni, Bozia. They have been contributing a lot to Sunoikis, as you know. And today we have, a popular session, I have to say, which is programming for humanists. You have the class outline in GitHub as usual, so you have a long session outline with a description, of course, of this session, and then you have many resources that Angelos and Eleni are going to show us. And I think that, so I'm saying popular also because Angelos and Eleni 2 years ago were in Leipzig and they tried this session in class with my students, and I have to say that it was really we had a lot of fun. And the goal of this session is to show basically how we can use natural languages to translate the computer code. So it's an interesting exercise, not only to help humanists, students and scholars to learn programming languages, to understand the logic of programming languages, but I think also for computer scientists to understand, okay, the language of programming, the programming languages. But anyway, so now we have online Angelos and Eleni, so welcome back.
Thank you, Monica.
Okay, good. I think we can start. Okay, now we have your screen and we can start.
Okay, thank you everybody for joining us today, and thanks to those of you who will be watching later on the video. In this presentation, we are exploring a topic that finds itself in the intersection of humanities and computer science. It is entitled Programming for Humanists, and is meant to introduce the concept of coding against the backdrop of language acquisition, a process with which humanists are very familiar with. However, learning coding is a challenging task, even for students of computer science, as it involves a different kind of procedural thinking, unlike the one that underlines natural language acquisition, with which we all as human beings are familiar. The method that my colleague, Professor Barmpoutis, will present in detail is based on the concept of natural language layering, an ontology-assisted way of programming in terms of natural language sentences that still preserves the syntax of programming languages. More specifically, we will present a novel source code editing method that assists novice users understand the logic and syntax of the computer code they type. The method involves an active tokenization algorithm that splits the typed code into tokens as they are typed and replaces them with pre-aligned translation in a natural language. The feasibility of the proposed method is demonstrated in 7 structurally different natural languages, as you can see on the screen: English, Chinese, German, Greek, Italian, Spanish, Turkish, Ancient Greek, and Latin, using examples of computer code in JavaScript. By now, it is widely accepted that learning programming is useful yet difficult. Issues range from difficulties in explaining programming fundamentals in a way that can be actually comprehended by students, so that they can then go more in depth, all the way to actually keeping students engaged. And of course, there have been studies in all levels of undergraduate education, with particular focus on computer science students. The majority of researchers and teachers have turned to game-based learning, which proved beneficial, but up to a point. However, further research has shown that students do not continue beyond that to explore more complex processes and levels of programming, or even subsequently fail to make the connections between the game and actual programming languages. Furthermore, one should also account for the age group of the students and whether game-based learning is actually the appropriate approach. On the other end of the spectrum, not enough attention has been paid to humanists and programming. The main purpose of digital humanities thus far has been to familiarize humanists with technology and provide them with skills necessary to study and promote their respective fields. However, it seems that coding has been considered yet another branch of technology not too easy to adopt. Regimented traditional curricula and a restricted views of what humanities should be about are only 2 of the reasons why humanists may find themselves with limited experience with computers, hence more reluctant to embark into programming. Additionally, as I mentioned before, there is always the inherent difficulty to relate humanistic experience with natural language to abstract programming concepts. Questions such as the ones on the slide have further complicated the teaching of programming in the humanities. And there have been several discussions, both in the form of journal publications, books as to how to teach programming to humanists, as well as discussions on the Humanists and on other humanities fora. Conversely, there are plenty of reasons why one should have a basic understanding of coding, such as, for example, the fact that 2/3 of NEH-funded digital humanities projects involve open source computer code, or APIs that are being developed, the databases that need to be maintained, and a variety of projects, of course, that are based on coding. It would be good if humanists could be able to develop some of the programming, the coding themselves, so that they can address the issues that they would like to be addressed, or at least that they could communicate in a more efficient way with the programmers that they hire, so that their questions, their research questions are better addressed. The novel method we are presenting explores the connection and ultimately bridges the gap between humanities and programming by establishing the fundamentals of natural and programming languages and teaching one against the backdrop of the other. The goal is to have humanities students work on the constructions of a sentence in a natural language and comprehend more deeply the logic behind traditional syntax. And at the same time, they are being taught the basics of programming against the backdrop of natural language syntactical construction. Therefore, students are more comfortable with the backbone of natural and programming languages and more adept at developing technical skills, all the while utilizing their familiarity with natural languages. Additionally, another one of our focal points is to enhance literacy in a technologically driven world. Literacy has been defined as the ability to identify, understand, interpret, create, communicate, and compute using printed and written materials associated with varying contexts. Going back to the Renaissance liberal arts education, one's ability to be fluent, so to speak, in grammar, dialectic, and rhetoric, as well as in arithmetic, geometry, astronomy, and music, could ensure one's success in the world. A holistic education that is predicated on theoretical principles that they then become also applied knowledge. Similarly, in a contemporary context, the aforementioned printed and written materials associated with varying contexts should also include computational literacy. It is not a matter of one substituting the other, but of interconnected such scholarly constituencies to develop well-rounded individuals. As technology is literally becoming integrated in the way we pursue our research and other scholarly activities, along with the fact that it is also an inherent component of everyday life in all strata, one should be able to identify, understand, interpret, create, communicate, and compute in this realm as well. This way, the power will not be lying in the hands of only a few computational literate. And of course, there is a large number of scholarly works and surveys for further reading on the topic. A topic that has been very well studied going back to the 60s, and we have a few references here, and you can also consult our GitHub page. And cases that they have been made, again, in publications and in online fora, why programming and literacy have similar trajectories, how we can use coding as a different language, again, not substituting actual language, but providing a different pedagogical approach, starting and going back in early childhood. All the way down to undergraduate education and why computer science should be a part of liberal education, and ultimately why all students should learn to program. A point that we would like to stress is that programming languages, like natural languages, become extinct, or some are more popular than others, or there are too many that are being used at the same time. So our method focuses on teaching the quintessential principles of programming, so that students may then be adept at being trained in any language application programming interface, so basically in any API. Developing tools for integrating computer programming in the humanities is not a new concept, and various tools have been developed to that end. One example that I have here on the slide is Inform 7, a design system that combines concepts from computer programming and fiction narrative to produce nonlinear interactive narratives. Another is SPL, the Shakespeare programming language, which is an esoteric programming language that was designed to make programs appear to be similar to Shakespearean plays. So again, different ways that we can approximate or we can relate, correlate, call it what you will, programming language with natural language and then fitting it in a humanities context. And metaphor, which is used to visualize stories as code, so doing basically the opposite. And the questions that arise, some of the questions that arise that we have here on the slide, and I'm going to pass it on to my colleague.
So now from the computer science perspective, there have been several tools to introduce basic concepts of computer programming to various ages. And in fact, computer education is a very well-studied topic, and there have been several methodologies proposed, and the tools follow basically those educational methods. And significant focus is on K through 12 education in order to enable students in early ages to create and acquire problem-solving skills, especially with focus to STEM education, which is the science, technology, engineering, and math. For example, one of the methods for early ages is tangible user interfaces, which has many advantages because it looks like a tangible toy. You can actually play with those puzzle sets, put together blocks that perform individual set of instructions. However, the drawback is that it's very limited. It's only for younger ages, and it's expensive as there is a cost attached to every single tangible block that you use in this particular interface. Then going to slightly later age stages, there are the equivalent to the tangible interfaces, but in the form of a software. So we have graphical user interfaces that resemble, again, those blocks that now you can move on your screen in order to solve a particular task. For example, create a small game. Now going even further, using an actual programming language with a real syntax, let's say of Java or JavaScript or Python, but with a very specific focus, for instance, to create a graphic design application or an audio remixing. These text editing interfaces have been proposed to create an additional motivation to early learners in order to grasp those new programming concepts. However, in our approach, we want to build a strong correlation between natural languages and computer languages. So it makes sense first to think, how do people encode and decode information? In other words, when I say encode and decode, I mean actually how to read and write, because from even from the perspective of programming, we read text and write text. So what I have been doing when I present this to conferences, I have a very small task, a very small question that I would like actually to pose now to you, which is an interesting way to see how people truly perceive information. So I will give you a very small line, a very small sentence, and I will try to ask you to decode this, to interpret this particular line. And this was first presented in one of my publications in 2017. So it doesn't matter if you know programming or no, please spend just a few seconds to try to interpret this line. Now, from experience, I have seen that many students have difficulty understanding what is the meaning of that. But it is very interesting that if I present exactly the same information in a completely different way, for example, this, which has a different context, it's a text message where it says, not sad or grumpy, be happy, then it's much easier to understand exactly the same amount of information. Now, what this small task proves is that context is significant. So in other words, it can help us memorize a particular sequence of characters that may not have an original meaning with them. For instance, a colon and parenthesis. Maybe this doesn't mean anything to us, but if we assign that to a particular meaning, for instance, a happy face or a grumpy face, maybe this will help us memorize that computerized syntax. And I'm sure that many of you use those type of shortcuts to type emoticons in social media. Now, this is not the first time that humans use this type of computerized encoding to type messages. For those who are old enough to remember the first type of mobile phones in early 2000, these phones were able to send text messages. So text messaging is not a feature of modern smartphones. Now, the problem with those early phones was that there wasn't any touchscreen or large keyboard to encode human language. Therefore, you had to solve this computer limitation and use the numerical 3x4 keypad and find a convention, a new encoding mechanism to type human language. For example, if you type 2 times 4, that's the character H, and 2 times 3, that's the character E, and 3 times 5, that's the character L, and that's how you type the message hello. What is more impressive is that, according to studies, those phones were widely accepted by more than 1 billion humans on the Earth, and they manage, according to studies again, to type 20 up to 26 words per minute, which is impressive and shows that humans can easily learn new computerized encoding of messages or of natural languages. Now, more recently, in 2017, another study was done in a set of volunteers who didn't have prior knowledge of Morse code. And as they learned Morse code, the research team observed through medical imaging how their brain changes. And what was very interesting is that they found that there is neuroplasticity in their brain observed visually, so you can actually see it on the medical images, not only in gray matter but also in white matter. So as you learn any of these kind of encodings, from typing emoticons up to Morse code or other computerized encoding methods, you change your brain. Your brain is trained to understand and encode and decode these type of signals. Now, going back to our topic, computer programming, an interesting study has shown that the complexity of learning computer programming does not change if we replace those English-based keywords often used in computer languages, such as if, else, for, etc. If we replace those with arbitrary hexadecimal symbols like B8, 7, F, or things like that, students will have exactly the same process through learning computer programming. So this doesn't make it any easier or any difficult, which is very interesting. So it's as easy for me to learn computer programming through those symbols that are English-based or not. Now, through all these examples, what we have observed is that language encoding and decoding requires 2 skills, a generative skill and a comprehension skill. So in other words, I need to learn how to write and compose new text, either programming or a text in natural language, and of course, how to read it. And sometimes one is slightly easier than the other. For instance, reading for a beginner who learns a foreign language, for example, has been many times perceived as an easier skill than generating, in other words, composing a new text in this new language. Now, I will bring specific examples. For example, the generative skill is encoding a character. Let's say I'm going to inscribe. It doesn't matter how I will do that. This character. Now, the other skill, the comprehension skill, assumes that I will read and understand a similarly shaped letter form. So in that particular case, I have inscribed omega, and I expect the reader to also conceive that as omega. So there is a symmetry between what I type or what I inscribe and what I expect the reader to read. Now, this also happens in modern text editing. When I type something, for instance, in computer code, when I type these symbols, if a exclamation mark equals 0, then I expect the reader who finds my code maybe in an online code repository to read exactly the same thing. So we have exactly the same symmetry property between reading and writing. However, all of the previous examples that we saw say that this is not always the case, especially in computerized systems where there are certain limitations. For example, you remember typing a message in an early mobile phone requires to type something completely different than hello. Of course, the readers will receive that message as hello, but the way that I inscribed it or I typed it into that phone is completely different. So we don't have any more that symmetry. And of course, the same is in the case of other computerized systems like Morse code, or even in the case of emoticons. I don't type a smiley face. I use a sequence of characters, but I expect the reader, when they receive that particular message, when they consume, they decode that message, will have a different mapping, and they will read a different message. Now, this also can be seen as a way of shortcut. I use some sort of computerized way as a shortcut to produce an outcome. And of course, we don't have symmetry even when using shortcut to close a window. Let's say in Windows, Alt F4, or in a Mac, Command W, they all produce an effect. They close a particular application, but we don't expect those symbols to be typed in the screen. I don't see Alt F4 typed somewhere as character on my screen. I don't need them to see. It's enough for me to see the result of that particular action. Now, I want to go back to this topic of the humanities. This is exactly the same as if typing, encoding a text in an ancient language, for instance, ancient Greek, using a computerized method. And this is a text encoding protocol that have been used many times to encode ancient Greek text, where the computer, of course, needs to know what are the corresponding symbols to go, and different accents that go above the different characters in ancient Greek. Now, by learning how to encode the text, it's this knowledge, this encoding, becomes an actual procedural knowledge for me. So I don't even need to remember those encoding schemes. I can just do it by memory. And many digital humanists have learned how to read and write ancient Greek text from by observing just the encoding that is shown on the left-hand side. But of course, it is expected that a beginner, someone who is familiar already with ancient Greek, will feel more comfortable on what is shown on the right-hand side. But people have learned how to use this mapping easily, and it has been shown advantageous to learn those encoding as well, as shown on the left-hand side. Now, from all of this theoretical background, what we proposed in our method is to use those observations in practice in order to help humanists or early or beginners to learn coding through the use of natural languages. So in other words, what we propose is in software developing tools, instead of typing, when we type a code, for example, if a exclamation mark equals 0, of course, that's exactly the programming language syntax, and that's what we need to encode. But when we decode it, we don't need to read those symbols, especially if we are beginners. It would be much easier if we read something much more explanatory in a natural language, such as if A is not equal to 0. Which explains, in other words, what the underlying encoding means. So in that particular case, the exclamation mark equals means is not. So the method is called emoticoding just because it resembles the way we type emoticons and was proposed in 2017. And it is based on the underlying learning in 3 stages theory, where the more we type this encoding, the more it becomes what we call procedural knowledge. Of course, in the beginning, we don't have the procedural knowledge. So by observing the explanatory statement, so in other words, by observing the English statement, if A is not 0, this gives us the declarative knowledge. In other words, the meaning behind that encoding. And the more often that we iterate this process, the more we type and the more we see the declarative knowledge, it helps us build this procedural knowledge. So at some point, we don't need to remember what it is. Automatically, it becomes an inherent procedural knowledge in ourselves, so we can stop using this emoticoding, and we know the programming, and that's our goal in that particular case. Now, this, in a sense, has been already used a little bit in some professional programming languages. For example, this is an example of Java, where we can see like numbers, jump 5, 45, or rest 90. But of course, now for someone who is the first time that uses this particular API, application programming interfaces, these numbers don't make any meaning. So if you observe this text in Android Studio, for example, you can see that there are some additional tokens that were not typed by the user, were automatically populated in this text editor. So in other words, we have an asymmetric text editor where what we see is not what we type. We see something that is much more explanatory. For instance, now everything makes a little more sense because it says jump with speed 5. So I understand that 5 means speed and 45 is degrees, and then rest 90 minutes. So now with those additional tokens that were not typed by the user but were shown by this asymmetric text editor helps us understand a little bit more the code. Now, what we propose in this method is to do that on every single token. In other words, replace every single token in the programming language and superimpose on top of that any schematic or word or phrase from a natural language. So I will show you an extreme example to understand the idea. So this is a simple code in JavaScript. Now I'm going to split that in every single token. For example, the first line consists of 5 tokens. Of course, this is an extreme example, but shows what goes behind our idea. So the first example is split into 5 puzzle pieces here. And of course, each of these pieces can be visualized in any way we want based on what is the audience, what is the particular age of the learner. And of course, we can gamify even this type of token replacements, or we can make it a little more serious using natural language. In this particular example, extreme example, again, we can see that number, the token that reads number in the computer program is the name of a variable. So it is shown in this method as a name tag number. Similarly, the symbol, the equal symbol is shown as the word B. Therefore, the first puzzle line reads let number be 1. And you can see similar conventions in other tokens. Here, for example, the plus equals, which is another token, has been replaced by be increased by. So the line number 4 now reads number be increased by 1. Now, of course, now it is our choice to identify what are these replacements and how we can help maybe users of different languages with this type of methodology. Here, I'm showing you a different example, which again, on the left-hand side, we can see the code in JavaScript, and on the right-hand side, we can see a different text replacement, in this particular case, in German. So I know that many students from our audience are German speakers. So in this particular case, we can see that some of the symbols, for example, plus equals, have been replaced now by a phrase in German. The same with the equal sign, as well as the keyword var, while, and we can see this alignment here. And this particular alignment was proposed actually by the students of Monica's class, as Monica said 2 years ago. Now the question is this a perfect alignment? Maybe does a perfect alignment exist in this particular scheme, or can you improve that alignment? And that is an exercise that we also posted in the GitHub. Now, I will show you how this works in action. And of course, this is an open source program that you can use by following this link. So feel free to do the same on your own. So here I type JavaScript and I use English text replacement. So you can see an object-oriented example where all the symbols, for instance, the dot has been replaced by '(s) to denote that this is a property of Bob, so Bob's speed. and here it's Bob's weight, and minus equals has been replaced by b decreased by, and you can see the entire program that is populated as I type JavaScript. So the encoding again is the target language that I need to learn, but what is shown as the comprehensive skill that I need to develop is English language, which helps me in different ways. First of all, for a beginner, the beginners can focus on the actual logic. So here in this sample script, we see some sort of logic where Bob is the variable, is a notion of a variable that is a robot. So therefore, this introduces the students to object-oriented programming. And then in object-oriented programming, there are certain things that you can do with this variable. So we can set some properties to Bob, to the variable Bob. So in that particular case, we use the object-oriented programming notion of accessing properties like Bob.weight, which has been replaced by the statement Bob's weight be 10, or we can ask Bob to do something for us, to run some methods, and this is Bob do run in this particular case to execute a method of this particular class. Now, the same example can be shown, of course, in different types of text replacement, and you can see exactly the same example in German. And as I change some of these, you can see how the different tokens are shown. So it's an interactive editor. The original encoding is never lost. I can go back and see what is behind Mach, what is behind Ende here, what is behind Bob's speed, and of course I can do that on different languages. So this is an example of modern Greek. I can show you an example of Italian here, we have encoded Chinese as well. So this is an example in Chinese, and you can understand how the early learners that are native speakers of these languages could benefit. And of course, we can always go back to the original encoding, which is the identity mapping in this particular case. What you type is what you see. Now, this method has been evaluated. I did several experiments in undergraduate students as well as K through 12 students, 5th grade students, and you can find the details of these studies in the papers that we provide in the GitHub. But just to give you the outcome of these studies, using different evaluation metrics to understand what is the difference, the change of learning outcome when they use this natural language computer programming. In most of these categories, the metrics have shown that we have a significant increase on the learning outcomes. In some of these metrics, they have even doubled the outcome, the learning outcome. So the students learn much more and much more efficiently using this type of interactive emoticoding editing.
So going back to Humanities or programming for humanists, rather, some of the exercises that we implemented have a humanities context. So based or against the backdrop of what Angelos presented before, as to what sort of text you can encode, and decode. So what are some actual texts on which we can implement this, and so that we can bring it closer to humanities curricula. So, for example, we can transcribe a theatrical play, and we have an example here from Shakespeare, how we can transcribe it into computer code. And why, just to explain the reasoning behind this or how this would work, is we try to accommodate, obviously, a form of literature that is very popular, that you can find in different languages. So the fact that we used here Shakespeare was so that we can have an example from everything, including modern and ancient languages. But the fact that you can accommodate a different language also shows that you can accommodate different cultures. So you are fitting this type of learning how to program into not only speakers of different languages, but you are also bring it closer to the context that someone can understand based on their background. And this way you can have the programming part adapt to the individual programmer and not vice versa. So how does this work exactly?
From computer science perspective, what we can teach in this type of examples is object-oriented principles. So in this particular case, any character that is introduced in the play is a variable, is an object in terms of object-oriented programmer that instantiates a class of characters. So the students, the learners understand from this encoding that, okay, Samson is a new character and Gregory is another character. And then we can set some properties of these characters. For example, what are their appearance, or what are the props that they are carrying, as shown in this example. And later we can ask those objects, those characters in this particular case, perform something for us. For example, they can enter the stage, they can exit from the stage, or they can say something, or they can move in the stage. So this again is shown as a method that is being called here, Samson do enter, or Samson do say something. And the overall procedure here, which is a programming procedure that is called Act 1, can be played. In other words, we have the entire play as if you actually read the script from the theatrical play, and you can choose which act to play right now. So this is the beginning of Act 1, and the code ends in the line 17 here. Okay, let's now play Act 1, which is the sequence of the steps that were defined previously. And now the equivalency between the what you saw over there and what was actually typed in the code is shown here. So we see that you can understand the alignment between what is the different symbols here, and some of them you have already seen in the previous examples. And you can see that there is let's say a method enter and the method say over here, and there are two variables created in this particular example for the two corresponding characters in this play.
Now, another example, and we thought that this would be fitting in Humanities curricula in a different way. It shows the coexistence of humanities and sciences, but science is being not computer science in this case, but since the text itself involves astronomy. So how to calculate how many days was the difference between the Julian and the Gregorian calendar when the latter was adopted. In this case, we try to make programming adapt to the individual programmer based on language, so we are using Latin, but also fit in within not only the humanities context, but fit in within the context, the actual living context of the person who is learning coding. Excuse me. As the text involves a different historical aspect, it also involves a religious aspect, and of course Latin as a natural language, but not a modern natural language, but actually an ancient natural language, which is our focus here.
From computer science perspective here, it's interesting to see that the code itself combines principles from history. So we see some dates that are the numbers here, the values of certain variables. For example, the first Council of Nicaea here was 325. So we need to find what is the discrepancy between the Julian and the Gregorian calendar between the year 325. So we need to type this as a variable, as the value of a variable, until when the Gregorian calendar was adopted, which was another historical fact that needs to be encoded in terms of computer code here, which is the 1582, and the actual token replacement that we use is Latin to resemble the original text by Pope Gregory XIII that introduces this calendar. So we can see the resemblance of some of the vocabulary over here, and we can see that according to this astronomical explanation, there has been a 0.0075 days discrepancy on every year. So how many days error was accumulated between 325 and 1582? By running this algorithm, at the end, the error is shown by the computer. and the corresponding computer code that was typed in the first place in order to see the equivalent Latin replacements is shown over here. And we can see that this example can be used to introduce learners to the concept of not only variables, but also loops. Loop is a concept that a particular piece of code is repeated for a number of steps until a test, a condition is satisfied. In this particular case, until we go to the age 1582, when the Gregorian calendar was adopted.
Now, the third exercise, the third example, fits perfectly as we deal with Euclid's geometry. We deal here, there are three divisions in the text, the definitions, the common notions and propositions, and we deal here with the common notions, which very fittingly combine ancient Greek, so we move to yet another ancient language, moving away from Latin though, but an ancient Greek text that is a mathematical text. And we have the translation here as well, but we also have the text in Greek for those of you familiar with Greek and Latin. And the syntactical structure resembles very closely, actually, the programming, the coding itself.
We can show actually an example of this. So as one of the exercises that we propose with this particular tool is to try to encode, for instance, number 5, the common notion number 5, into computer code. So if two things are equal, so I will create two things. A, let's say it's 10, and B is also 10. So I do have two things that are equal. Then according to Euclid, then 2 times A should be equal to 2 times B. That's exactly what this fifth common notion says. So I'm going to type, then if 2 times A is indeed equal to 2 times B, then I will say that this particular common notion is right. So Euclid, then the program will say that Euclid is right. Otherwise, then this is not true, so Euclid is wrong. So we can actually ask the computer to evaluate this small piece of code and prove that the fifth common notion here is actually right. And as Eleni said, that there is a similarity in the vocabulary used here with the original. Some of the words are exactly the same. For instance, the equal, and you can see what are the different phrases and keywords that have been used to replace JavaScript here in the first place. And it's interesting to observe this as if it was actually typed by Euclid in the first place because of this common vocabulary that was used with the original. And here you can see what is the correspondence between the phrases and the different keywords that were used, and with the corresponding typed JavaScript text that is shown here on the bottom of the slide. Now, in those examples, we chose those particular 3 languages. We saw an example in English text replacement, an example in Latin, and now in ancient Greek. But of course, you can see how this could be extended even further in other languages. For example, here is Chinese, and you can see how our concept of that. Many students, beginner students, think that, okay, this is strange, I cannot understand the text as is shown here, is subject maybe to encoding. So many of you may think that, oh no, I cannot understand the text as shown in here, so maybe this encoding is not proper for you, as the JavaScript encoding is not proper for others. Maybe we need to find something that is more familiar to you, maybe to the natural language that you know. And as I said, I know that many students in our audience speak German as their native language. So here you can see, for example, the alignment between the same example from Euclid as shown in German here and as shown in English on the right-hand side. And again, is this the perfect alignment? Is this the perfect set of keywords and tokens that can be used? That's exactly our question, and maybe you can contribute a better alignment, or maybe you can contribute an alignment in your own language by following the link that we give over here. So if you follow that link, you will be able to contribute a language that we don't have currently in this tool set. So we will be very happy to give you credit, of course, for your contribution. Now, Another interesting observation is by switching from one set of text replacements to another, and this is shown exactly the same example in Italian and in Spanish, you can even see the cross-alignment between the text replacements. So you can see some similarities between the different languages. Of course, some languages have more similarities than others. So it's an additional layer of correlation between not only computer language and natural language, but between natural languages themselves. So here you can see the alignment between two natural languages as alignment to the original JavaScript, the underlying JavaScript in here. So in a sense, we can think JavaScript as the connecting point between the languages that are shown in this particular example.
And of course, we are not making the case that you can learn how to speak a modern language based on this. Obviously, we need to simplify the natural language itself in order to bring it closer to programming language, to coding. But being able to learn how to code or to learn any skill, basically using a language that you're familiar with and not only be forced to learn it in English, can make a big difference. And then, of course, it can help the cross-alignment between different languages can also help for speakers of multiple languages.
And another benefit is that the same framework can be used across ages. Recently, computer programming, principles of computer programming has been introduced in younger ages, in elementary schools. Now, in that particular age, the students may not know already English, and as you know, programming languages like JavaScript use many English tokens. So maybe it could be easier for them to observe the code in their own native language that they just learned to read, exactly as is shown here. For example, modern Greek students or Turkish students, elementary students could benefit by coding in this environment and learning the first programming principles in something that is much more familiar to them.
And particularly for younger age students, even if they do have some basic knowledge of English or of a foreign language, when you are dealing with concepts of programming that have to do with mathematical concepts, it is easier to actually comprehend what you're talking about when you are using your own language, when you are counting, when you are, it's more innate to understand it in your own language rather than using a different language to count, for example, even if you know how to count.
Now, there are many questions that we need to address, of course. Excuse me. Is straight alignment possible between every programming language and natural language? What are the different grammatical or syntactical problems that we may observe by trying to align computer code to natural language? And maybe from the examples that you already have seen, you observe some of these syntactical problems. What natural languages can be used and are better for this type of alignment, and what programming languages can be used? In most of these examples, we use JavaScript, but can we do a similar alignment for other programming languages, such as Python?
So the method we presented today is based on the relationship between natural and computer programming languages, which has been a topic of research, as we've tried to show you, from multiple perspectives. Now, both types of languages follow specific sets of rules that constitute the grammar of each language, whether that is a computer language or a natural language, and use distinct bodies of words, that is the vocabulary, again, either programming tokens or actual vocabulary. The key differences, however, are their flexibility in expressing a message in multiple different ways and the context in which they are utilized. Although natural languages can be used in many different contexts, programming languages is primarily used to precisely describe a set of actions to be performed by a computing device. Now, natural language can be translated to computer code under certain conditions, and machine translation of a computer code to a natural language, such as English or otherwise, can be achieved using statistical machine translation algorithms and has many applications, including understanding the logic of the program by reading its pseudocode and generating automatic documentation in a natural language, as we saw through all these examples. So coding can be used to visualize natural language in the form of storytelling. And conversely, storytelling can provide useful insights about coding. In conclusion, programming has infiltrated, as you see also from the slide here, our personal and professional lives. If one wishes to be an active agent and enhance traditional literacy with computational literacy, either in the form of basic understanding or at the level of writing code, their scholarly and civic contribution can be actualized. Case in point, programmers have effectively coordinated in the 2010 Haiti rescue operations. Coding also facilitates medical processes and has an impact on civic procedures, such as voting. And I only have two examples here. For example, you can run a simple search, and this is a humanities on the left-oriented example, a simple search on the Google Books as to where you can find the use of the word race. And you can see the percentages that the words has been used throughout literature, going back to the 1800s up to, I believe it was 2008. And then when you go deeper, if you're a humanist and you understand how that algorithm runs, how it actually works, you can draw interesting examples regarding sociopolitical issues, historical issues, or simple use of the word in literature, answer simple philological questions. But again, you can be simply a user of the Google Books Ngram viewer, or if you have some basic understanding of how this works, you can utilize even the results that you are shown here. You can use them and you can comprehend them better. On the right-hand side, the example that I have on the slide applies more to programmers who perhaps want to find a more an actual, practical, everyday example of how they can use coding, programming. And there is a non-profit organization, for example, that is Code for Social Good. And on the screen says it doesn't matter if you code for fun, and then they switch the word fun. If you are a programmer, if you are not a programmer, if you are doing it for personal reasons, get started now. And it's the picture here shown is from an actual demonstration for women's rights. So there are different ways that you can use programming in different contexts, or again, if you do not want to program yourself, if you understand how it works, you can be a more conscious user of the results, at least, that you are shown. On the other end, knowing, for humanists again, knowing how Amazon's Alexa works and comprehending the way artificial intelligence engines in social media function can make us more conscious scholars who can contribute to society and the world by being more civically alert and sensitized. And similarly, coding can empower humanists to teach the world about humanities and human politics, and I use here the word politics in the Aristotelian sense of the word politics. Finally, being able to utilize technology to our discipline's advantage, whatever that discipline may be, and convey our message to a larger audience can make us actors, as I said before, and not just viewers, or at least can make us into viewers who understand what they are viewing. It is not a matter of choosing, substituting, or promoting one discipline, disfavoring the other, or for that matter, it's not a matter of substituting programming language and being reductive to natural languages. It is actually a matter of one empowering the other. And by familiarizing ourselves with programming to any degree, we are not being reductive to anything, to natural language or to literature, because computational brevity, through its variegated applications, as I showed you a couple of examples before, can spread very wordy messages. Twitter only allows users to message in 140 characters, for instance, and even though such brevity has been accused of encouraging superficiality, which may be one side of the other point, we've all been witnessing the power of the 140 characters. And as Umberto Eco noted, to be or not to be, that is the question. Man is a rational, mortal animal, veni vidi vici, phrases and ideas that have marked the history of humanity, and they were all briefer than 140 characters. Thank you.
Okay, so thank you very much, Eleni and Angelos. It's always a pleasure to listen to this talk, because it's super interesting and there are really many things we can discuss about. So there are people also on YouTube following us, so please ask questions if you have questions. in the meantime, maybe 2 notes. Well, first of all, you mentioned the fact that you had to simplify the expressions of natural languages. Well, yes, of course, but I think that we can immediately see how natural languages are more verbose than programming languages, and how English is very powerful in this sense, because with, in the end, very few terms, we can have many instructions in a programming language. And then the other thing about your example about Shakespeare is interesting to see how a text, in this case, Shakespeare's text, is a sequence of instructions for actors. So this is really wonderful to compare Shakespeare's text of Shakespeare and the performance, of course, and also how to translate it into a programming language. While we wait for...
I would like to comment on your first observation, and I would say that indeed having a code into a natural language increases significantly the cognitive load. So in other words, there is a significant brevity in just 2 symbols when we see a typed code compared to a whole phrase, maybe in a natural language. So the question is, what is for us easier to understand? Something that with significantly higher cognitive load, like a full text, like a book, or something that is just a bullet point, like a programming language. Many have argued that a good slide, for instance, if in a slide in a PowerPoint presentation, for example, is like a bullet point, just a brevity with just one short phrase that you can easily understand, compared to the increased cognitive load of another text. But I will, in case of someone who is beginner, showing, for example, just a mathematical equation, so which is easy to understand for an audience and is very simple. For instance, the integral symbol of a function. For someone who is beginner, it's much easier to say now that this means that the area between the function and the horizontal line. So providing a more lengthy but explanatory message is the declarative knowledge. But of course, your observation is right. This is much more busy. The cognitive load is much larger. So as you become familiar with that, and your knowledge, declarative knowledge, becomes procedural knowledge over a period of time, it makes sense to switch to the more simplified computer code.
I think we need both. Well, when I tried, and I'm still trying because I'm not a programmer, definitely, but every day I try to learn more about programming languages. As a philologist, I always want to understand everything, the use of if, else, while, okay? But this is the way philologists think. But I think this is important. Of course, we have to learn as philologists not to use too many words, okay, but to try to be brief. On the other side, I think that for computer scientists, maybe sometimes they just learn to use those terms, forgetting the meaning. I don't know, this is my experience, of course, but my perspective is the perspective of the linguist, of the philologist. And definitely I'm not so young anymore, because when I started, when I was a young student, the situation was different, but now we have this mixed program. So this, I think this is really a super interesting part. And I remember that when we tried in class in Germany to translate the code into German, of course, it was difficult. And we had computer scientists in the class because, of course, German, as many other natural languages, needs more words. So I think this is a super interesting exercise. But now we have a comment in the chat.
Yes, Anise.
Our friend Anise. Okay.
Yeah, we will thank Anise for her willing to contribute the Portuguese. We made it now slightly easier, as if you follow the instructions that we have, and we also posted the instructions in the GitHub of Sunoikisis. You can download let's say the database that shows the alignment, and you can simply complete that list with the language of your choice. In that particular case, you can add Portuguese and follow step by step the instructions and see the translation maybe that have been used in other languages, and that will become make it easier for you to choose what is the best keyword or phrase in Portuguese if you see what was the selection made in English or other languages that you may know.
Yes, we have a very active community in Brazil, and this in this SunoikisisDC term, definitely we have many requests for Portuguese also in previous sessions. So, and definitely today we have another opportunity also for including, for example, Portuguese. I have another question about your work, because Sunoikis is an international consortium of digital classics and digital humanities programs, and we usually discuss about the content of our sessions, like in this case, programming for humanists, but you have been, and you are working a lot for producing programs for both humanists and computer scientists. And you showed us, Angelos, percentages about your students. Can you, and in this case, of course, you are based at the University of Florida and your work is there, but you are contributing, of course, to other international programs. But my question is about your work now, so your results, for example, at the University of Florida, where you have, as it is happening in many other places, like in Leipzig, where I have a mixed audience. So originally, your need was to involve humanists in programming, how to teach students to in the humanities to program. How is your experience today? In 2020, your results, your questions for the future. I know this is a big question.
Initially, we did start as programming for humanists, and again, for obvious reasons that we presented today. But then, as we started collaborating, for example, with your students. So basically, in the process of trying to translate these into other natural languages, modern languages, so that humanists can use them, we realized that it's not only an issue for humanists as to how to learn how to program, but it's also an issue for computer science students. And this is why I hinted at that in the introduction of the session today. What I'm trying to say is that we take it for granted. Usually we take it for granted that programming is something that you do in English. And when you know that something is a status quo, you usually go along with it. However, as I said, when we started using and collaborating with computer programmers to translate this, we realized that it perhaps is not something that we should take for granted, that English should be the language used. And yes, programming languages use tokens in English, but how much easier would it be if anybody could learn it in their own natural language? So again, the focus, even though we thought that this whole environment, programming environment, would be of help and would facilitate humanists, we then realized that we can see it the other way around, that actually we are using language, our language, to learn how to program, which benefits everybody. So then the advantages became multiple, and even things that, to be honest, we hadn't thought from the beginning.
And then someone can think of the bias that has been included in most of the professional computer languages, as they all use keywords and phrases in English, even syntax of English language. So from the terms of diversity and inclusion, how can we create the proper tool or the proper modification of the existing programming languages in order to resolve this English-oriented advantage in the current programming languages and make it more approachable to other native speakers, especially now as we try to introduce, as I said earlier, programming principles in early ages. So far, someone could argue that the majority of those who have interest in programming probably already know English. Therefore, this is not an issue. But now, if we try to introduce that in younger ages, this is not true anymore. So in younger ages, they may not have grasped a foreign language like English in an adequate level to use it as a mechanism to program through professional programming language. So the tool also can be seen as a mechanism for diversity and inclusion, if you will, in computer programming.
And it's an issue that in classics we have started having discussions about this in the conference we both attended last week, for example, how we rely on bibliography that is primarily English, and even though that is understood up to a certain extent, we are more familiar, it's more widespread, it's more publicized, whatever that reason may be, but it's a matter of inclusion. We do have scholarly works that are being written in other languages. So people start being more alert now to the fact that if we want to produce, why shouldn't we be enabled to produce in our native environment, whatever that native environment is? So again, even though we started as, okay, humanists find it hard to program, then as we started working with different groups of people for translations, for some experimentation, etc., we were opened up to a whole other world of, okay, so why just in English, and why do we take this for granted?
And I would like to add to that context is very important. Yes. If we say, if we go to a class of any humanities subject and we say, okay, now I will teach you programming, it's out of the context. So we need, what is missing is context. So what we try to do with the examples that we showed in this presentation is to add that missing context. So if programming becomes an interesting task to do an English course that studies Shakespeare, or it's an interesting task to do in someone in history, like the example with the Gregorian calendar or astronomy in that particular case, or someone who studies Latin or ancient Greek and study Euclid, for instance, from the original text. Then programming has a context, has a particular context, and becomes an interesting exercise for someone from that particular subject to do. So if we provide the why you need to learn programming and why this could be interesting for you, and approach it from your own perspective, what you know to do well and what you know to read well, then if the students gain those necessary programming skills, then we can introduce them to other reasons why programming is good for the humanities, such as all those interesting tools for performing analysis, text analysis, and there are many wonderful open source application programming interfaces that can be used if someone knows programming.
Thank you for this comment, because this was important. Of course, diversity and inclusion are two keywords today. There is a big discussion in many contexts, of course, today also in these months. And now we can also see how we can experiment this, also studying actual sources. And I have to say that being a classicist and a philologist, I'm very happy to see what is happening, because as you mentioned, we started with a specific need in an academic environment to involve humanists and also classicists, because I know that especially you, Eleni, you are a classicist and you work with students in classes, so a specific need in a field. Then now we can really see many other possible scenarios involving computer scientists, and then involving, of course, native speakers, kids, also children. Yes, it's true. Because we take for granted that everyone knows English, but this is not, also because we have another background, being not native speakers. So it's super interesting how we can see many different possibilities starting from this specific need for diversity and inclusion. So really, thank you very much for this point, for this comment, which is important also for our program, which is specific for digital classics, a subfield, but we can see how in some way we can contribute also to other fields and other disciplines. I think there is another comment by Anise following the previous discussion. She was asking, okay, to show your results.
Could you return to the results? You should have the different metrics percentage.
Yes, of course. If I
you can share the screen again if you want, if you can.
Yes.
Okay.
So the question is if we could elaborate a little bit more on these results, and intentionally this is a screenshot actually of one of the papers, and the reason for not making a pretty graphic here is to motivate the audience to go back to the actual original paper and see what is the table for, as shown in this particular case, and what is those metrics that in detail are presented in the paper. Just briefly, since you asked me that particular question, the experiment that was performed in this particular study involved teaching very specific programming concepts, variables and conditionals, to a class of 5th grade students who visited actually my lab at the University of Florida. And after having that particular learning session, and they experimented with those two concepts, variables and conditionals, and then at the end of this learning time, they had to go to solve, let's say, a small to write a small exam, if you will. I asked the particular questions to compose a statement that introduces a variable, then to create a conditional that checks the value of this variable, and create a small logic using those two concepts. At the end, I received those papers, those exams, and I evaluated those based on the accuracy of the use of variable, the accuracy of the use of conditional, the accuracy of the particular syntax, and the accuracy of the logic. So some students had correct logic but incorrect syntax, and some students did correct variables, some others the conditionals. So different metrics, exactly as described, were established, and I split the students into two pools. One pool was learned those concepts using this tool that we developed, and the other pool of students learned exactly the same concepts, but using the conventional programming text editing. So there were no text replacement in that particular case. So those percentages shown in this example is the difference between those two pools of students. In the first metric, as we can see, only 17% of the students who learned programming using the regular computer text editor managed to correctly solve that particular challenge, while this percentage was increased significantly, more than doubled, 52% for the students who learned the same concept but using the proposed metric. And you can see that this evaluation was done across other metrics as well.
Okay, so thank you. I had the same question about that slide. Okay, so our time is over now. Of course, I know that we can have many other questions, but you have the session online, so there is a full description with examples, and most important of all, you have readings, because there are scholarly papers about this work by Angelos and Eleni, and there are also exercises, and basically they are about the examples showed in the slides. I'm reading the exercises. Okay, so that's it for today, and I'm very grateful to Angelos and Eleni. I know that this semester was super busy, stay at home, but with a lot of teaching, a lot of work, and also conferences. So really, thank you for your time. and for your contribution to Sunoikisis. It is really also, it's always great. And so next week we have another session, a different topic, because we will talk about classical prosopography, but we will see a project developed by Rada Varga, Romance 1 by 1, which is a database of information on ancient people. So we see information about ancient people for working on prosopography, but the session is about classical prosopography using relational and graph-based approaches. So again, the effort is to start with specific projects in classics and then expanding to see how we can use technologies and also how we can involve students with a computer science background to understand more about our needs, and vice versa, of course. So thank you again, Angelos and Eleni.
Thank you, Monica. It's always a pleasure to contribute and see everybody and talk to everybody.
Yes, exactly. We are stuck at home, but at least we have the technology to see each other. Okay, so thank you. Good night for those in my time zone, and good afternoon, something like that, for Angelos and Eleni. And now I think you deserve your lunch, definitely. Okay, so see you next week, and bye-bye.
Ciao.
Bye.